We're now going to look at finding areas of a triangle that is not a right triangle. So we're called to find an area of a triangle. That area K of a triangle is equal to 1/2 times B times H, where B is the base and H is the altitude drawn to that base. So let's look at a triangle. Let's say we have the following triangle. Let's say that this was A, this is B, and C. So this would be side B, this would be side A. So opposite angle B is side B, opposite of angle A is side A, opposite of angle C is side C. Let's draw our height, H here, and we created a right triangle. So the area K here, this is equal to 1/2. Let's look at the, 1/2 times our base, which is B in this case, times the height. Well, let's look at finding that height. So we know, let's look at angle A. So this left triangle, angle A, opposite of A is H. And so let's look at using sine. So H, we know, or sine of A, is equal to the opposite H over the hypotenuse. In that case would be C. And so H in our case here is C times sine of A. So K, the area is 1/2 times our base B times our height C sine A. So that was using the left-hand triangle when we made it a right triangle by putting in the height. If we looked at the right-hand triangle as we cut it into two, we could say, well, H, or sine of C, is opposite of angle C is H all over the hypotenuse. So the hypotenuse in that case would be sine A. So our height in this case is equal to, multiplying by A on both sides, we get A sine C. So we could also say that our area K is equal to 1/2 times our base, which was B, times our height, which is A sine angle C. I could take this triangle and I could rotate it. So let's rotate it so that I can look at the formula with using angle B. So if I rotated this, let's say, and now this angle B here is on the left-hand side. So if that's on the left-hand side, that would be A here, not to scale. This would be C here. We can create, again, a different height. Our height in this case, if we made a right triangle, I wanted to use angle B. So using angle B, opposite is H of 1. And then a hypotenuse would be A. So we know sine of angle B is equal to H of 1 all over A. So the height in this case is equal to A sine B. Okay, so let's look at K then. K is equal to 1/2 times the base. The base in this case is C, times our height, which was A sine of angle B. So notice it's the sides and then the angle that is sandwiched in between those And between those two sides is going to give us that formula. So K is equal to 1/2 B times C sine of A. K is equal to 1/2 B times A, or A times B sine C. K is equal to 1/2 A times C sine B. So that is the formula for trying to find the area of a triangle when we're given two sides. So looking at this, we have a triangle in front of us. We're given that our angle A is 30 degrees. We're given that side B is 3 and side C is 4. And we want to find the area of this triangle. So our area K is equal to 1/2 times our base. Our base in this case is 4, times the other side that we know, 3. So those are sandwiching the sine of what I'm taking, 30 degrees. So the area is equal to, well, simplifying this, I know 2 goes into 4 twice. So 2 times 3 is 6, times sine of 30 degrees, which you should know, which is 1/2. So the area is equal to 3. If I had units in here, I would put units, that unit squared. It's okay, the area is 3. So now let's look at the case where we're just given 3 sides and we don't know any of the angles. So there's a formula that we can use, which is called Heron's formula. Heron's formula says to find the area when you're given the 3 sides, you want to figure out what S is. S is equal to the perimeter, so summing all the sides divided by 2. And then finding that value of S, we can find the area. The area is equal to the square root of S times the quantity of S minus A times the quantity of S minus B times the quantity of S minus C. So let's say, for an example, we're given that our side A is 4, our side B is 5, and our side C is 3. And we want to find the area of this triangle. So first thing that we want to do is we want to figure out what S is. So we want to sum our sides, 4 plus 5 plus 3, and divide that result by 2. So we get S is equal to 4 plus 5 is 9, 9 plus 3 is 12, 12 divided by 2. So S is equal to 6. So we can find this area by Heron's formula. This is equal to the square root of S, which we found to be 6. And then take S, 6 minus one of the sides, 4, all times S, which is 6 minus another side, so let's say 5. And then all times 6 minus the last side, which is 3. So we have the area is equal to 6 times 6 minus 4 is 2, times 6 minus 5, which is 1, times 6 minus 3, which is 3. I get 6 times 2 times 3. I notice this is 6 times 6, which is 36. So square root of 36. So our area here is 6. So we were able to find the area of that triangle just given the 3 sides. So now let's look at an example where we're looking at an application of finding the area. So the following problem says the Bermuda Triangle is roughly defined by Hamilton, Bermuda, San Juan, and Puerto Rico, and Fort Lauderdale, Florida. Okay. Okay, so it's Bermuda Triangle is roughly defined by those 3 places: San Juan, Hamilton, and Fort Lauderdale. The distances from Hamilton to Fort Lauderdale. And Fort Lauderdale to San Juan and San Juan to Hamilton are approximately the following: 1,028, 1,046, and 965 miles respectively. Ignoring the curvature of the Earth, approximate the area of that triangle. Okay, so we know the three sides of the triangle. And so we know we need to figure out what S is. So S would be the sum of those three sides. So sum of 1,028 plus 1,046 plus 965. All of that divided by 2. So plugging that into the calculator, 1,028 plus 1,046 plus 965, we get 3,039. All divided by 2. Let's see why my computer's frozen. So if we take that sum divided by 2, we get that S is equal to 1,519.5. So the area of the Bermuda Triangle is equal to the square root of S, 1,519.5, times the difference between 1,519.5 and 1,028, times the difference between S, 1,519.5, minus another side, 1,046, all times the difference, 1,519.5, minus the last side of the triangle, 965. So let's just throw this into the calculator. We have the square root of our answer times that answer I'm just putting in, which is 1,519.5, which is already in my calculator, minus 1,028, all times my answer, minus 1,046. My answer. Oops. Minus 965, close that. So taking the square root of those products, we get that the area is approximate the area, and it didn't say to what. And those are all whole numbers, so I'm gonna say this is approximately 44,282 square miles. Okay, so we just found the area of the Bermuda Triangle using Heron's formula. So that is both of our sections of our textbook, 9.3, law of cosines, we did today, which was on a different video. I split this up into 2. And then we also did the area of triangles. And that is 9.4 in our textbook.